IVM.
Welcome to All Things Policy, a daily podcast by the Takshashila Institution. We are a bunch of policy nerds based in Bengaluru, and we like bringing fresh perspectives to Indian affairs and Indian perspectives to global affairs. So grab a cup of coffee, sit back, and join us for today's chat.
Hello, folks, and a very warm welcome back to All Things Policy. Today, the two of us, Aditya Pareek and me, Aditya Ramanathan, welcoming a special guest. We're joined by Hari Pulakkat. He's a veteran journalist. He's covered business and tech, and most of all, science. He's really known as a science journalist. He's based in Bengaluru. He's the winner of the Indira Gandhi Prize for Popularization of Science in 2020. He spent 3 decades of his career writing for the Economic Times and Business World, and he is presently editor of a science and technology magazine published by IIT Madras called Shastra. So welcome to All Things Policy, sir.
Thank you.
Right. In your book, you go through a lot of the details about Indian scientists, and you tell the story really of Indian science through them. Your book, Space, Life, Matter, and that title really covers the 3 broad subject areas that you look at in that volume. What I'd like to ask you first is, how did you get interested in science? Well, what got you into science journalism?
So it's an accident. So I used to read a lot of books on science. When I started working, I moved to Delhi and had access to a library for the first time in my life. A good library, I mean. So I started reading books on science, and I could see the difference between what we studied in college and what I thought was real science. So some of the books I read was The Second Creation, which I found really captivating. A history of particle physics in the first half of the 20th century. And then Richard Dawkins, The Selfish Gene. I also read books written by journalists, by Robert Canigal, The Man Who Knew Infinity, which had come out just a little bit before I started work. And it was quite fascinating. And I thought this is a good thing to do in life. So I did not start as a science journalist. So then after 3 years, when Business World started expanding, I asked Jane Ninen, who was the editor of Economic Times and then who moved to Business World and Business Standard, whether I could do that. And he said, yes, it was as simple as that. But having started that, it was actually a long struggle because in the mid-90s, there was very little science in India that you could write regularly for a magazine. Business World was fortnightly, but still we had to find stories every 2 weeks. It was not easy. But over a period of time, I learned how to write in peripheral issues and wait for the right moment to write up a proper science story. And it became easier and easier because the science also expanded. And by 2010, we had a reasonably big science ecosystem in the country.
Right. Yeah. When I read your book, I'm really fascinated by a lot of these stories that you have in there because, some of these things you hear about anecdotally from someone, but I've never seen it, in a properly researched text like yours. And I really like that you have chosen to use the lives of the scientists to tell the story, or at least tell the story of Indian science through them. Now, what really struck me, especially about the post-independence period, is that some of these people came back to India or stayed on in India, in the case of Homi Bhabha, for example. And, they were basically foregoing these very fruitful careers abroad. Can you tell us about some of these scientists and also what was it that drove them to work in India?
Okay, Homi Bhabha's case was sort of an accident because he had no intentions of coming back to India. He was doing very well in the UK, in Cambridge. He had discovered some new physics, Bhabha scattering, which had his name as well. He came to India for a holiday, and then World War II started and he could not go back. So he was sort of stuck. And that led to his founding of the IFR because he found that there was no institution in India there where he was comfortable working. Even at IISc, he found the research was quite old-fashioned. So he wanted to create a modern institution where he himself could flourish. And that led ultimately to the creation of the IFR. But in the case of almost everybody else, the situation was different because they wanted to work in an independent India. And they had seen when you go outside and work And in the best of universities, you see how different things are. And it is natural to feel that you could create those conditions in India if you work long enough and work hard enough. So that prompted them to come back. The sort of idealism, nationalism, whatever you want to call it. Nationalism, not in the sense that you understand now, but at independence, nationalism, before independence, that meant just independence and nothing else. So they were motivated primarily by a sense of belonging, and they wanted to build India through science and technology. Almost all of them. If you want to list them, Govind Swarup first, B.V. Srikantan. B.V. Srikantan didn't go abroad in that sense. He did his PhD in India, but he did go after that. M.J.K. Menon, who gets only a passing mention in the book. M.M. Sharma, Satish Dhawan, U.R. Rao, J.N. Ramachandran, Mashelkar. A.V. Ramarao did not go abroad again till late in life. He did his PhD at NCL, worked at NCL for 5-6 years before he went to Harvard for a postdoc. But then he was clear that he wanted to come back. All of them had a sense of purpose. They wanted to build a modern India. And that sense lasted for a very long time, through the 50s, 60s, 70s. It's only in the mid-80s and I sensed that it started becoming a motivating factor, stopped becoming a motivating factor.
So this is not directly related to the book, but what is it that you think caused this sense of patriotism to start declining in the 1980s?
I think it's a natural consequence of when a country becomes independent. The first few decades, you have gone through the independence struggle, and you experience that and feel proud that the country is independent and would want to build it. So slowly over a period of time, the new generation wouldn't have that sense of, they haven't gone through the struggle. They have read about independence movement, but reading and participating in it are two different things, right? This is my guess. I don't have any clear answer to this, but I think this is what it is.
Yeah, sure. That as a hypothesis, that definitely makes sense. I mean, when I look back at some of these earlier scientists, for example, it's extraordinary to think that India built the world's largest radio telescope by the year 1970. Okay, this was a time when India's economy was much smaller than what it was today. And at least to me, it's hard to imagine India pulling off an equivalent feat like that today. So my question to you is really, did those early pioneers of Indian science think bigger than us? What were the circumstances that allowed the sort of ambition of Govind Swarup setting up this world's largest radio telescope? What was that circumstance that allowed that ambition to thrive?
So it was not just the largest telescope and radio telescope in the world. It was 4 times larger than anything that was built at that time.
Wow.
So again, circumstances contributed. If you look at a bit about Govind Swarup's history, he was doing very well in Stanford, but he wanted to come back because he had seen the struggle of independence. He had also participated in the Quit India movement. He had seen from school and college. School, I think. Yeah, school. So he was clear he wanted to come back. But when you want to come back, he came at a very crucial period in his career because he wanted to be known as an astronomer. So he wanted to discover new things. He had problems in his mind for which he wanted to have a solution. And one of them was the Big Bang Theory. So there were 2 competing theories at that time. One was the Big Bang Theory, another one, the steady state theory. And there was no proof for either. Most people believed that the Big Bang Theory was correct. Big Bang Theory meant the universe originated in an explosion or a flash or a sudden expansion, more correctly, about 10 billion years ago. And at that time, people thought it was 10 billion years ago. Now we know it's a bit more than that. It's about 13.8. So he wanted to solve this problem. He wanted to find evidence for Big Bang. He had the opportunity to work in the US at Bell Labs, but he had already decided that he had to come back. So once you come back and you want to solve this problem, you have to have the equipment. But he didn't have the equipment. And he didn't know what to do. At that time, serendipity intervened, and he was reading some research papers, about the discovery of quasars. And there was another paper in the same issue of Nature, which used a technique called lunar occultation. So When he read that paper, he realized that he could use that technique. And if he built a large enough dish, he could use that technique and improve his resolution and probably look right at the time when the universe was born. Almost, when maybe about 7-8 billion years into the distance. I mean, he could look into the early universe. And if you find that the early universe looked different from the current universe, it means that the universe had evolved. You can't see the Big Bang, but at least you know the universe was different. And what he wanted to see was how close were the galaxies to each other. If they were very close to each other, that means the universe has expanded since then. So he had no choice. He had to build something. And when he saw this paper, he realized that this is what he has to do to discover this. Well, unfortunately, by the time this telescope was built, somebody else found evidence. But he found additional evidence with the new telescope. For most of the people at that time, there was no choice. They had to do something extraordinary to do some decent science. That is not the case now, because you don't have to think like this to publish a few papers in a frontier area. You have the equipment. You can, the equipment is not as good as what you find in the US or Europe, but it's still good enough. So there is no pressure on them to think like this. But even then, it was quite an extraordinary achievement, because it was not just building something. He had to build everything. He had to build the entire team. There was no industry. Nobody could do precision engineering. So it was truly a massive project, and he pulled it off. It was amazing, actually.
Yeah, it is really amazing. My mind is blown away by it. And I also just think of, another case that you talk about. I don't want to give away all the stories you have in your book, but the other...
So before we go on to the next question, I want to say...
Go on.
So anybody, who's interested in astronomy should go and take a look at the telescope in UT. It is open to the public. It is still there. It still works. And if you see it, you realize how big it is. Measurements and numbers do not do justice to what it really is. It's truly massive and mind-boggling.
Absolutely. I really look forward to seeing that telescope myself one day. And it's really fascinating, the whole story of it coming into being. Another extraordinary story that really struck me from your book was that of how India built its first satellite. And this project began in Peenya, which is now an industrial area outside in the outskirts of the city where we're recording this in Bangalore. And, back then, Peenya was basically a village.
Yes.
And this project was carried out in these rundown sheds. You had many of these team members who were basically kids right out of college who were learning things from scratch.
Yeah.
It's such an unlikely story. Can you just tell us how on earth it happened?
Again, you have, first of all, the atmosphere at that time was very conducive to space engineering. So it was a time when just after Soviet Union launched Sputnik, and Kennedy had made the go to the moon speech, and Apollo mission was going on, and everybody in the world was interested in space. And now Indians read about these things, and then suddenly you have an opportunity that you have not dreamt of. You're called, you have a job in a space organization, and you're asked to build a satellite. Even if you don't know anything, I am sure most people would put in their best efforts, right? Which is what they did. And like in the case of UT telescope, you had one person who had some experience, that is U.R. Rao. He was the only person in that entire division who had seen a satellite. None of the others had seen a satellite. They had no idea what a satellite was and what it did. So people who were recruited, their bosses asked them, do you know anything about satellites? And they say no. And they asked the question back, do you know anything about satellites? No, they don't know either. So everybody was at the same level, and they had to learn, they had to read, experiment, and then build it. It is good fun, I suppose. If you have this kind of responsibility, it's like a dream. Especially in the 60s, when space was the area to be, and the 70s. This happened in the 70s. It was just after Apollo mission, but the space program had started in the 60s. The satellite program began in the early 70s.
Right. Yeah. I suppose that one thing that struck us, both of us, thinking about the satellite program is both Aditya, Pareek and I track India's space sector. And I suspect, some of the energy that you saw in the building of India's first satellite, you perhaps see with India's own startups today. So in the space startups.
Exactly.
So maybe that spirit is very much still alive with us.
Yeah. The India was a startup nation at that time. We are no longer a startup nation. So in startups, people pull off the impossible sometimes, right?
Yeah, absolutely.
And let me just bring this up. So today's episode is actually pretty enlightening for both of us, because Aditya Ramanathan and me, Aditya Pareek, we both have been trained as journalists in our college degrees. So interacting with a science journalist is something that is very close to our heart. So, we both read your book, and it appears to cover a wide range of scientific achievements in India. So, to give our listeners a sense of the range of subjects you cover, can you tell us a bit about G.N. Ramachandran and his work on collagen?
Okay. G.N. Ramachandran was probably the best scientist India has produced. You could say C.V. Raman, and G.N. Ramachandran was his student, but the quality of his work would match that of C.V. Raman. And there are many people who think that he was better. Well, at least he was one of the best. So after his PhD, it was not a PhD, it was a DSc. Then he went to Cambridge and did a PhD. But most of his learning was probably when he worked with Raman. And then he came back, and then the Vice Chancellor of Madras University, Mudaliar, invited him there to set up a physics department. And there was absolutely nothing there at that time in Madras, in the university. G.N. Ramachandran wanted to do crystallography. He wanted to look at what is now known as structural biology. So you need to have X-ray crystallography machines, good cameras, computers, and things like that. They didn't have anything. But GNR was already trained to work with minimum equipment, because that was the tradition of Raman. So, and he picked collagen. He didn't have a molecule, but then later decided on collagen, and CLRI director Nayadama gave him some collagen, which is a protein, which is in terms of, this is the most abundant protein in the human body. They did not know the structure of collagen at that time, and protein structures were being solved, just beginning to be solved. He started work in around early 50s, and they had solved some protein structures. So collagen was considered to be a very difficult molecule. They knew the nucleic acids, the amino acids in collagen, but they didn't know the sequence. They didn't know how it led to the structure. So GNR figured out that this was sort of stroke of genius, that every third molecule was a glycine, and he proposed this helix, a triple helix, which was not accepted initially. He published papers. Nature held on to that paper for some time, and then they published it. There was some criticism, some questions, and he did more work and published a better one, more improved model, which turned out to be correct. And then there were still questions. Francis Crick, who later discovered he had already discovered the DNA structure, thought that some of the atoms were too close to each other in his model, and they could not come that close. So here he did something unusual. Instead of figuring out just for collagen, he did the general. He solved the problem in a general sense. He figured out the allowable configurations of atoms in all proteins, which is what led to his Ramachandran Map, now called as Ramachandran Map, which is considered to be his most important discovery and part of textbooks. And he went on to set up the molecular biophysics unit in the Institute of Science, which later led to structural biology in India and a very large team of structural biologists. Several of modern biologists in the country are products of that department, including the Director General of CSR now, and one of the previous generalists.
So in the life section, you also talk about two more eminent scientists of India who've made a specific place for themselves. So could you tell us a bit about how you cover the relationship between them, and was there something peculiar about the correspondence that they exchanged?
Satish Dhawan was the director of Indian Institute of Science. In fact, the modern Indian Institute of Science was built by him. It was he who expanded, he brought a new culture of working. It was considered to be a very laid-back institution at that time. And Satish Dhawan energized it. It brought in a large number of faculty, young people from abroad, grew the institute, and got people to work together and did a lot of things. And it was Satish Dhawan who brought G.N. Ramachandran from Madras to Bangalore. He was supposed to be an institute professor, working with everybody, but then GNR started a department and it grew very, very quickly. It was not supposed to grow that quick, at least not in Satish Dhawan minds. Balram was one of the people who joined molecular biophysics unit at that time. So he had come after a PhD from the US. And since it grew so quickly, and since space was anywhere limited in the Indian Institute of Science, he could not get laboratories. I mean, nobody in NBU could get decent laboratory space. So 2 years later, Balram wrote a letter to Satish Dhawan that, this is not a good working environment. Let's see, we have to, somebody has to oblige us for us to do our work and so on. So Satish Dhawan didn't get back immediately, and then he wrote again. Actually, that was not what happened. Meeting with Satish Dhawan, and he didn't get it. And then he waited for a long time. Then he wrote a letter. And then finally, a year and a half after he came to IISc, Satish Dhawan met him. And then once he understood the problem, he acted very quickly. And then got Balram's space and chemical engineering department, which he had already seen. And then Satish Dhawan went around, checked everything. And it was that place where Balram worked for the rest of his life there. And he left it 2 years after he retired as director of Indian Institute of Science.
Yeah, I'm really struck by how this fairly small number of figures have been so responsible, have loomed so large in the evolution of science in India since independence. One theme, if you will, that...
Well, India was a small country at that time.
Yeah.
India is still a small country, if you look at only science. And at that time, it was still very, very small. So because of this, we feel that, the small number of people had contributed. Everything grew from them, right?
Absolutely, yeah. It has to start from that small base. But another thing, a theme that pops up through your book is the sense of constraints, that there are lots of constraints on scientists. The environment in which they work is difficult, and there is that lack of equipment. Now, you've talked about how that has changed, at least to the extent that, that basic equipment is there, even if equipment in India does not match that of the West. So I guess my two-part question to you would be, how much has that changed, really? If you can give us a sense of how much that has changed. And two, since there will always be constraints, are there lessons to be learned from this frugal approach that Indians have taken to science?
Okay, things started changing early in this century. Things actually had become worse through the 90s, because after liberalization, funding for science became stagnant for a long time, through a decade. Early 2000, the government decided that we have to expand. There was enough pressure from scientists. It was a new government at that time. So from 2000 till now, I think India's investment in science has probably gone up by 4 or 5 times. The size doubled, more than doubled. There were 300 universities early in the century. Now we have about 900. So it is this expansion, the extra money, that brought new equipment to science. But it was it was a consequence of what scientists did at that time, because they relentlessly lobbied against the government to create institutions that would fund science. So in the 80s, they created the Department of Science and Technology, and then later the Department of Biotechnology. So till then, India didn't have a mechanism to fund science. You give money to Indian Institute of Science, and that money had to be used for research. It was a very small sum. But after this, departments were created. A researcher could write a proposal and get a specific project-based funding. And that project-based funding also had money to buy equipment. So, but on the other hand, I don't think we're still as good as the West. I mean, in fact, it's quite behind, because not just the money, but the time it takes to do something. If a new equipment comes in the West, it always comes in the West, because we don't have private companies that can make advanced equipment still. So by the time it comes to India, it will take a year or two, probably 3 years. I would say, you can look at the example of the Cryo EM, the Cryo Electron Microscope. It arrived in India, the first instrument arrived in India 3 years after it was invented. And most other, it was more than 100 instruments had been sold by them. And then it took another 3-4 years for everybody to get, all the leading institutions to get it. So that means scientists in the West have a lead start in most cases when their work has to be based on advanced equipment. But on the other hand, scarcity, I think, is present everywhere. I mean, even in the West, they don't always get funded for the amount of money that they want. And some areas get funded more, some other areas do not get funded. So I think scientists will have to learn to work with scarcity everywhere. And even Europe and the US and Japan and probably now China is still less than 50% of the world. Not in terms of number of scientists probably, but in terms of population. So at least half the world is severely short of funds. And although this so-called frugal science of forgery engineering is not really a technique, because it's just learning to work with, learning to be innovative when you have constraints. And there is no specific methodology. The world can still learn a lot from India, those countries where funding is not that high. And it will be the case for a long time.
Absolutely. Can I also ask you, just before we wrap up, do you want to talk about what you're working on next, what your future projects are, if any?
Well, this book is still bothering me because it is a very rich area, and I don't think I've fully finished it in my mind.
Okay.
So whether I will update it with a second edition or whether I'll write a new book, I don't know at this moment. But it's
No, obviously, you've just finished this book.
Yeah, I'm also interested in the history of Indian mathematics. I'm looking at it seriously, and some of the scientists mentioned in the book, I think, deserve much more than what I've done. So I'm looking at that also deeply.
Absolutely.
I don't know what I will write, but I've just finished, right, about a couple of months ago. So
no, that was an unfair question. Yeah. So anyway, thank you so much, sir. And I'm sure that you're going to be profiling Indian science and India's scientists a lot more. We'd also like to hear, like you mentioned, about India's mathematicians. And we're really looking forward to whatever you write next. I will just say to our listeners that I would unreservedly recommend the book. It is a terrific read. You'll just zip through it. The title is Space, Life, Matter. So thank you so much for joining us on All Things Policy, sir.
Thank you, Aditya.
If you liked our show, don't forget to check out other interesting podcasts on the IVM network. You can tune into them on the IVM Podcast app, ivmpodcast.com, or wherever you listen to your podcasts. You can also follow IVM on social media. The handle is @IVM Podcasts on Twitter, Facebook, and Instagram. And hey, if you'd like to dive into Takshashila's research on technology, strategy, and economic affairs, check us out at our Twitter handle @TakshashilaINST or our website takshashila.org.in.
I hope you enjoyed that show. If you aren't following us on social media, please do. We're IVM Podcasts on Twitter, Facebook, and Instagram. We'd like to thank the sponsors on the network this week, Cred, PayPal, and Siet. Thank you. We really do appreciate the support. So this week on Cyrus Says was great. We had Meghna joining us on Cock and Bull, Tanveer Taj and Priyanka Jena talking about pets. Yuma Qureshi talks about her new television show and her life in Bollywood. And to celebrate 700 episodes on Cyrus Says, we had a number of his previous producers come on board and reminisce. Tune into This Round is on Me, where Gauri Devidayal was joined by Samir Sheth and Yash Panage. These are the guys who started Bombay Canteen, O Pedro, and a number of other restaurants. Really great conversation they had with Gauri. On The Habit Coach, Ashton Doctor tells us about nourishing creativity and the importance of losing and some micro habits to counter overthinking. On their 75th episode, Ritasha and Rayushi talk to Naveen Richards. On The Note with Monica Nayat, she speaks with Komal Nahata to talk about the business of Bollywood, lockdown losses, piracy issues, and experiments being done to keep it going. On Advertising is Dead, Varun is joined by Guru Bhatt, VP of Customer Success Platform for PayPal India, to talk about how the digital money landscape and the fintech ecosystem has fundamentally altered the world. We also have Thalarate, our Kannada podcast. Hosts Ganesh and Pawan discuss video games, and Sivakamyam Sabatam, the Tamil show where Kavita Jiva sheds light in another story about the bravery and excellence in the governance of the Pallava dynasty. And with that, I hope to see you again next week.
Do you know Tamil? Tamil Puriyuma? Do your children enjoy great stories that inculcate good values? Hi, I am Ravishankar Balachandran and I host the Storytime Tamil podcast. I am excited to share a short story with great moral values every day. Listen to Storytime Tamil on the IVM podcast app, YouTube, or wherever you get your podcasts from.